I am going to share with you very important points about a gas filled type detector of elementary particles known as GM counter. First of all, let us see on what principle this counter works. The principle is very simple. Gas molecules get ionized when an energetic charged particle propagates through the gas. The electrons produced by ionization of gas can cause further ionization of gas molecules if they are accelerated by some high potential. Due to further ionization of gas molecules, a large number of electrons are produced. Now let us see what are major parts of a GM counter. The GM counter basically consists of a hollow cylindrical tube of length about 15 to 50 centimeter and is made of copper. This tube is also known as GM tube, and it is filled with some inert gas, generally argon, along with 10% vapors of ethyl alcohol. This GM tube is enclosed in a partially evacuated glass tube. A tungsten wire of about 0.5 millimeter diameter is fixed along the axis of GM tube, but it is held insulated from the tube. The wire is connected to positive terminal and GM tube is connected to negative terminal of a high tension battery. A thin window is provided on one side of the tube for entrance of the particles to be detected. Now let us come to working of GM counter. When an energetic charged particle enters the GM tube, the gas molecules which interact with this charged particle get ionized. The so generated electrons get accelerated towards center anode and positive ions towards cathode tube. The accelerated electrons cause ionization of more and more gas molecules. This phenomena is also called avalanche. The avalanche gives rise to very high current pulse. For each particle entering the tube, successive current pulses are produced, and the counting of particles is done with the help of a counter to which the pulse is sent through an amplifier. After this, let us touch some theory parts of GM counter. First of all, a very popular term regarding GM counter is dead time. What is meant by dead time of GM counter? We have seen just now, during working of GM counter, electrons and positive ions are produced. The heavier positive ions take enough time to reach the surface of cathode tube. Until all these positive ions reach the surface of cathode tube, the next particle cannot be detected. The interval for which GM counter remains completely insensitive to the next coming particles, this time interval is called dead time of GM counter. Mathematically, it can be expressed by capital T equal to 1 upon small n minus 1 upon capital N, where capital N represents particles entering the tube per second and small n represents particles counted per second. Next important point to be discussed here is what is meant by quenching of GM tube. We have just studied what is meant by dead time of GM tube. Just on the completion of this dead time, the positive ions reach the surface of cathode tube and get discharged there. As a result, a current pulse is again generated. The generation of this current pulse indicates as if another particle has entered the tube, which is not the case in reality. So, a single particle is counted twice, once at the starting of dead time and the other at the end of dead time. Hence, it is desirable that this positive ion sheath formed must be eliminated before it reaches the cathode tube. This process of eliminating undesired positive ion sheath formed around the central anode wire is called quenching of GM tube. Many methods have been suggested for quenching of GM tube, but the most acceptable method is known as self-quenching method. Now let us see what do we do in this self-quenching method. In this method, some halogen gas is introduced in the GM tube. The accelerated positive ions of inert gas collide with halogen gas molecules and ionize them. The electrons so created neutralize the inert gas positive ions, and the positive ions of halogen gas, being light, get rapidly drifted towards surface of cathode tube, where they also get neutralized. In this way, inert gas positive ions are neutralized. This is called self-quenching of GM tube. The next point to be discussed is what is meant by plateau curve of GM counter. For that purpose, let us note some important point definitions. First of all, what is meant by counting rate of GM counter? It is nothing but the number of particles counted by GM counter per second. The graphical representation of variation of this counting rate with the potential difference between anode and cathode is called plateau curve of GM counter. The potential at which current pulses just begin to appear is called threshold voltage of GM counter. The portion of plateau curve within which counting rate remains almost constant is called GM region. From this graphical representation, we can calculate relative plateau slope as explained in giving relations. In the last, let me share with you what are advantages and limitations of GM counter. First of all, the advantages of GM counter over other popular detectors are that the particles entering the window at very high speed can also be detected with the help of GM counter because its counting rate is very high. Second advantage is that a large impulse is created So very little amplification is required in this case. Next, it is a portable instrument. It is also useful for mineral prospecting purpose. It is very useful for the study of cosmic rays. In spite of these advantages, there are some limitations also. This GM counter cannot be used to detect uncharged particles. Second limitation is the record cannot be kept permanently because the component is bulky. It cannot be sent in balloons for the study of cosmic rays. Thanks a lot. I expect comments from the viewers and I will try to respond to those comments also.